This is problem 70 of chapter 8 of Giancoli 6th edition. So what we have is a cyclist that accelerates from rest at a rate of 1 meters per second square. So what we know is that this object is initially at rest, so initially the velocity is 0, and it accelerates with a certain rate, which is given to us. Okay? And they tell us how long this bicycle keeps accelerating, so they also give us the delta t. They give us the diameter of this tire. Let's see if we are going to need it. The diameter, we know it's related to the radius. The radius is just the diameter divided by 2. Okay. With this information, we will know what is the velocity of this bicycle after this time has passed. For this is just a translational motion. We can just use those equations from chapter 2, and we can find the velocity of the center of mass is just the initial one plus the acceleration and the time. Very well. The question of the problem is the following. How fast will a point on the rim of the tire at the top be moving? So let's have a look at this tire. Here we have the tire. All of the points of this tire are moving with the same velocity of the center of mass. They are all translating, and let's assume translating to the right. So each one of these points will have the velocity of this center of mass, including the center of mass itself. All of these points have to be moving to the right. So this is the velocity of the center of mass for all of the points. Since the bicycle is moving together, all the points of this bicycle are moving together. But at the same time that the whole bicycle and all of the tires are moving, they are also rotating. This wire is also rotating. So each point in the rim of this tire also have a tangential velocity, which I'm going to put in red. Okay, so here I have this tangential velocity, here I have this tangential velocity, and here and here. Okay, so you see that at the top, the two velocities involved have the same direction, the tangential velocity and the velocity of the center of mass. So I'll call this velocity the tangential velocity. Okay, now this tire, it's rolling. Okay, so it's not sliding against this floor, it's just rolling. So if it's just rolling, each point just touches the floor and moves away. So the instantaneous velocity of each point with respect to the floor when it touches the floor is just 0. That's what defines an object that is rolling and is not sliding. That means that here at the bottom, the magnitude of the velocity of the center of mass is equal to the magnitude of the tangential velocity. This is an important information. This tells us that the tire is just rolling. The tire is not sliding. Okay. From that, I can then come back to the top and find what is the total velocity of this point at the top. Is the sum of the two, the tangential and that of the center of mass. And since the tangential and the center of mass have the same magnitude, this is just twice the value of the magnitude of the velocity of the center of mass. More interesting are the points in other positions of this tire, right? Well, at the bottom we know that the velocity is 0, and these ones, for example, at this position, how would we find the velocity, the net velocity? We would need to use this right triangle. How about this one? Well, here again, we would need to use this right triangle, so Pythagoras, to find the velocities at these more interesting points.